Welcome to today's episode. We're diving into a fascinating topic, the interplay of security in the Linux kernel, particularly through a concept known as the linux-kernel-defence-map. This unique framework helps us understand the relationships between vulnerability classes, exploitation techniques, bug detection mechanisms, and defense technologies. So what does that mean exactly? Well, let's start with the basics. The Linux kernel is the heart of the operating system that powers millions of devices, from servers to smartphones. Given its widespread use, it becomes a prime target for vulnerabilities and exploits. Think of it as a huge fortress where occasional weak spots can be found. Now, imagine if you had a map that illustrates all the potential vulnerabilities in that fortress, paired with the tactics attackers might use and the defenses in place to counter those attacks. That's essentially what the Linux kernel defense map offers. It's like a GPS for security experts navigating the complex terrain of kernel security. One interesting aspect is the interplay between vulnerability classes and exploitation techniques. Vulnerabilities can be broadly categorized, like buffer overflows, race conditions, or privilege escalation, and each class comes with its own flavor of exploit techniques. How do attackers leverage these weaknesses? Well, think of them as different tools in a toolkit. Just as you wouldn't use a hammer to screw in a light bulb, each exploit technique is chosen based on the vulnerability in question. Now let's talk about bug detection mechanisms. How do we find these vulnerabilities before attackers do? This is where things get super intriguing. There are a variety of tools and methods: static analysis, fuzz testing, and even code reviews, each serving as a magnifying glass to identify weaknesses in the code. But here's the kicker. Even the best detection tools can miss things. This is why continued learning and adaptation are vital in security practices. Speaking of adaptation, that brings us to defense technologies. With every new exploitation technique, defense mechanisms evolve too. Think of it as a game of chess. An attacker makes a move, and the defender must anticipate and counter. Technologies might include things like address space layout randomization, ASLR, or kernel address space isolation. These are like the walls and moats designed to keep the fortress secure, but even they can have vulnerabilities. So why does all this matter to you? Well, if you're a developer, system administrator, or just someone interested in tech, understanding the kernel and its vulnerabilities can help you make better decisions around security. It raises questions like, how do we build more secure systems? What practices can we put in place to safeguard our data? As we're wrapping up, let's reflect. The Linux kernel defense map is more than just a chart. It's a living document that helps us understand the vast and ever-evolving landscape of security in the kernel. It challenges us to stay informed and proactive. So as you leave today, consider this. What steps are you taking to fortify your own digital fortresses? Until next time, keep questioning and keep learning.